Hey guys, welcome back to my channel, and I'm back again with another really interesting coding interview question video. This time guys, we are going to solve question number 2331, evaluate Boolean binary tree. Before I start the problem statement guys, just want to request you that if you have not yet subscribed to my channel, then please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. Let's get started now. So basically guys, the problem statement says that we have got a Boolean binary tree which we have to evaluate. This binary tree is a full binary tree. What is a full binary tree? A full binary tree is a tree which can either have a 0 node as a child node, or it will have only exactly 2 child nodes. Okay, so for example in this, it's a full binary tree. Either you have got leaf nodes. If your node is not a leaf node, it is having exactly 2 child nodes. Okay. Now in this case, it has written that if you have got a leaf node in this tree, then they can either have a value 0 or 1, where 0 represents false and 1 represents true. But if you have got a non-leaf node, then they can either have a value 2 or 3, where 2 represents Boolean OR and 3 represents the Boolean AND. What we have to do is we have to do the whole evaluation of the tree, complete Boolean evaluation, and return that answer. Okay. For example, if we come across a leaf node, then the evaluation is the value of the node, right? So if it's a leaf node, it can either be true or false. But if we are not at a leaf node, then we are going to take the value of the child nodes, evaluate the expression of the root node. So if the root node is OR, then we are just going to OR the 2 child nodes and return that value. If it's AND, then we are going to AND the 2 child nodes and return that value. Okay. So you can see in this example, we have got 2 child nodes here, false and true, and there is an AND. So obviously, if you AND both false and true, you will get false. Now in the root node, you have got OR. So if we OR true and false, the answer is going to be true. So that becomes our whole answer. Another example guys, you can see that there's only one single node having 0 value. So because it's a leaf node and it evaluates to false, we are returning false. The constraints are that the number of nodes in the tree is in the range from 1 to 1000. So we know that there is going to be at least one node. Okay. So it will never come across that there is like no node. There is going to be at least one node. And then and then the node value is going to be from 0 to 3. Every node has either 0 or 2 children. The leaf nodes are having a value of 0 to 1 and 0 or 1, and non-leaf nodes are having 2 or 3. So now that the problem statement is clear, let's jump to the solution part. So this is a tree evaluation guys. So we are going to do this recursively. The most important condition in case of recursion is our base condition. And what is our base condition? Our base condition is this, that if the node is a leaf node, then the evaluation is either the value of the node, which is true, or false. So in this recursive function, the first thing I will check if this is a leaf node or not. So if root dot left is equals to null and root dot right is also equals to null, then it's pretty straightforward. Okay, then we just check that if the root dot value is equals to 0, it means return false. And if its value is not 0, then it's definitely going to be 1. So we just return true. This becomes my base condition. Now coming to the non-base condition, when we are at a node which is a non-leaf node. So if my root node is a non-leaf node, then I am going to check if the value is equals to 2. So what does 2 means? 2 actually means that this is a OR evaluation. So if it's an OR evaluation, then I am going to evaluate the complete left subtree. That means pass the evaluate of root dot left. I am going to OR that particular whole left subtree result with the whole right subtree evaluation. So OR evaluatory root left with the OR evaluatory root right, and this is going to be my answer. Same thing. Just I'm going to change the operation, that if the root value is equals to 3, it means I am going to evaluate the whole left tree and AND it with the whole right tree and return that. If any of these conditions doesn't hold, then we just return false as our final condition, just to have a return statement at the end. So let's run this code, guys. Let's see if this works. And you can see that this is accepted for one example case, and now it is accepted for all. Now talking about the time complexity, guys, this is a simple tree traversal function, and thereby the time complexity in this case is going to be order of n. Why? Because we are traversing the entire tree having n nodes, and to each node we are visiting once. Space complexity is also going to be order of n, guys, because this is a recursive function, and every time you recursively call this function, you go into a stack, and because it is being called n times, we can say that the space complexity is order of n. Okay, so that was the solution, guys. I hope you guys liked the solution, and I hope it became a bit helpful in your coding practice. If it did help you guys, then please do not forget to like this video and share this video with your friends. Write down in the comment section below anything you want to say to me. All your feedback is definitely welcome, guys. And thank you so much for watching. Please do subscribe to my channel, hit the bell icon for future notifications. I'll see you guys in the next video. Until then, take care and bye bye.